Okay, this is Shawn Farris for the Storyboard and Game Design class for Full Sail University, explaining my class diagram and my flowchart. First, we'll have a look at the class diagram. Um, Everything starts with the sprite and the Collider 2D information that's already provided by Unity 3D. These are components that will be added to a static object class. You need to be able to pull out the X and Y of this class, even though they'll probably be included in the sprite for the purposes of snapping. There will also be a bool that determines whether this object casts a shadow or not. If it casts a shadow, it will add a component to do the shadow rendering. Derived from the static object class are the gravity affected objects and kill objects. Kill objects are not affected by gravity, and the only additional variable that they need is a blood texture, which when triggered they'll apply to the floor or the ceiling near them after they kill somebody. All gravity affected classes will need to know what the gravity is within the game. Going down from there, the static game objects will derive from the gravity affected objects. This is a special subclass for objects that can be pushed, and they'll have information within them registering whether they're being pushed by the character. Also derived from the gravity affected object is the overall character controller class, which also will add the component of the animator in. The important variables that this class adds are the X rigid body force and the Y rigid body force, as well as the speed at which the player moves. So the rigid body force determines for X left and right movement, Y is the jump height, and the speed determines how fast the character moves. Coming out of the character controller, there'll be three primary classes that derive from that. The first is the projectile, which is the simplest of the three. This is only going to use the rigid body and have the ability to determine which direction it was cast by, so that way it'll fly in the right direction. The player class needs the ability to attack and have a jump force for it for jumping. The enemy class will have a simple class that adds attack and HP, because the enemy class is the first class that actually can take more than one hit of damage. Deriving from the enemy class are the two specific types of enemies. The flying enemy class, which has a simple move to distance AI, which will allow it to chase the player but doesn't have extremely complex AI, whereas the grounded enemy class will have a move to distance component that expands into the movement AI that allows them to run on the ceiling or on the floor. And that is the breakdown of my basic classes for the enemies and the character controller, as well as the objects that appear in the scene. So now I'm going to go over and take a look at the flowchart for the character controller that the player uses. Upon start, it'll get the level start information. We've broken out when the system gives input to the controller as yellow objects versus blue input for the player. After the level is started, the game will set the bool for dead to false, send the player to the player start position, which can be fed by this D node later by spawn points or save points. It'll also get the component's animator, so that way if this is on more than just one type of player, it'll be able to get that animator dynamically. Whenever we have something that needs to be fed to the animator, it's going to be this kind of orange color. So after start, it moves into the spawn call. This is where it'll actually send the player prefab to the position it got from the start position. It'll wait for the physics 2D overlap, which lets the controller know if it's sitting on the ground finally. If it's not sitting on the ground, it'll continue to wait. If it is on the ground, but it is not it is the first time that the game is respawned, it'll disable the loading screen. If it's just a regular respawn, it'll end the spawn animation. From there, the player controller moves into its main function, which is waiting for player input. At the end of a lot of these inputs, they'll feed into an A, which will feed back up here to the player input. The most important thing that can branch out of this is if the player is dead. If it's dead, then it needs to go back up here into the spawn prefab. If not, it's going to sit and wait. It can get a couple of external information without player input, such as collision 2D. What it does is check to see what that collision tag was, and then it makes decisions based off of what the tag was. If it was a save spot, it checks is it a new save spot. If not, it ignores it because it's already recorded that as the player spawn position. Is it a new save spot? Yes. And then the game will check, is this the final save spot? If it's the final save spot, it'll move into the final checkpoint and end of level. If it's not the final checkpoint, it goes into update the vector 2 of the spawn, which sends it to a D, which comes back up here to feed the player start position and our start commands. Otherwise, coming out of that collision 2D, if the enemy object, or if it collides with an enemy object, it'll determine whether the player is alive or not. If the player is not dead, it'll send dead animation information to the controller. So it sets the variable for dead, runs the death animation, sends dead to the animator, and will send the overall component back up to C, which goes into the initial spawn again for the player. If it's a static object, it doesn't need to do anything special. It'll just go back to the waiting for input. If it's not colliding with anything and not getting any input from the player over here, then the player controller sends idle to the animator and the character is just idle. From there, the player has 5 input choices that they can feed to the character controller that have different effects. The first is jump. It checks the same physics overlap circle to see if they're grounded. If they are grounded, it'll apply the rigid body force to the Y, pulling in the jump force variable that the controller is given, send a jump to the animator to make the animation, and then it'll go back up to the waiting. As you can see, the grounded information is fed from B, which is up here in the ground check. This will constantly run during fixed update. The next option the player can have is shoot. The game will check to see if the shoot is on cooldown. If the shoot is not on cooldown, then it'll spawn a projectile, go into the spawn projectile function, and send the animator the information that the spawn has been true for a projectile. If it's on cooldown, it'll just go right back to A and waiting. Now the move forward and move left have very similar functionality, with the exception that the collision 2D will feed information about whether the player can move in that direction. If it can, then it'll feed the x plus or the x minus into a vector 2, times that by speed, and add that to the rigid body force. This force is math absoluted down to a move that's sent to the animator, because the animator doesn't need to know if you're moving left or right, it just wants to know if you're moving at all in order to call the walk animation. It'll also move to the flip function, which determines whether the player is moving in a new direction than they were facing, which flips the sprite scale, and I'll show that in a second. The last big input that the player can give is a gravity swap, which the game checks is the gravity swap on cooldown. If it's not on cooldown, then it'll take the current gravity, feed it into a swap, and then go back to waiting and send an animator value that swap is true. If it is on cooldown, then it'll ignore the call and go back to waiting. A couple of quick functions that I spoke about briefly in this that can be fed by the controller are the flip function, and what this does is check to see if the player is moving the direction that they weren't originally facing. If so, it toggles the flip bool backwards. It also switches the vector scale by timesing by -1 and then goes back to waiting. The player can also call a spawn projectile function within the character controller. This determines whether the player is flipped, feeds that to the spawned object if it is flipped, so that way the spawned object will appear facing the right direction. Then it applies forward force to that object, and the object has an internal projectile update that checks for when it collides with something. And that is the breakdown of my flowchart.